the same yapon, wala siya rotation. Okay? Nag-move siya. Ang isa, still moving but not translating. It's just rotating, no? Just like an electric fan, no? Steady, no? Rotate lang siya. Okay. The third type of motion is we have the general plane. Okay. In general plane is one siya kanang combination is a translation of fixed axis rotation. So it translates and at the same time it rotates. Okay. So mo ni siya ang gitawag nato types of plane motion. Okay. Translation, fixed axis rotation, and the general plane motion. So, rigid body translation, mga klase, doon na tayo, linear and then curvilinear, no? Curvilinear. Now, the rigid body is assumed to take the general plane motion type, no? As it travels in a straight path. The same with the curvilinear, no? As it travels in a curvilinear trajectory, the rigid body moves in a general plane motion, meaning that it translates and sometimes it rotates. That is why your equation is, you have three, no? You have translation and rotation. Okay. Now for the rectilinear, we have this, no? We have this rectilinear. Okay, so our project, our lesson for our last problem is about rigid body translation. Okay, meaning we are only going to use the second Newton's law. Okay, now this is the last problem that I will be using Newton's second law. And as we know, Newton's second law is force equals to mass times acceleration. Okay, and then we are dealing with the linear translation. Okay, so the problem goes like this, no? Have you seen a conveyor? A conveyor na ang work sa conveyor is really to transport products, no, from other point to other point, no. So it could be translating up by just inclining the conveyor system, or could be just horizontal, no, moving from A to B horizontally, no. Conveyor system is very common in factory, no, when you're moving products to the other area without the use of people, no? Meaning it uses the machine. So conveyor, just like the chain of a bicycle, no? It just keep coming out, no? But the chain is made up of a belt with some idler at the bottom, and maybe we have a driver, no? Usually ang chain sa bike, move na siya because somebody is turning the pedal, no? It is the rider, no? As he moves the bike, so the chain also will move. Now, conveyor belt works like that. So doon na lang isa ka driver sa unahan, then the rest are just idler, no? Now the belt is utilized as the carrying part for the product. Okay? So dito, para sa kanang conveyor sa kanang like the conveyor belt of the kanang sa mga airport bitaw. So lagpad lang na kaya conveyor belt, no? That's useful to transport baggage, no, from the other point to the other point. Okay, but here the problem is not only horizontally inclined to give niya ang conveyor belt, no. So the conveyor belt moves up, no. So bringing the cylinder, no. Ato lang tawag og sardinas, no. Okay, ang sardinas common man, no. Nga cylinder. Now the cylinder has the diameter half the height, no. Meaning ang height niya is equal to 2d while the lateral dimension is diameter. Okay, unang giinulya. But another information is that the conveyor, the angle of inclination of the conveyor is 15 degrees. Okay, so the conveyor is plated, no. So doon na siya mga plates. So purpose ng plates is so that dili gid siya mo slide, no. Dili siya mo slide accidentally, no. Okay. Now, there are two scenarios here. So, kung paspasan ang conveyor, o lagi, is possibly nga matumba ni siya. Matumba. No? So, malangan na noon. Imbis kay they have this production to meet, din ano makamit sa production. Why? There's always stopping time of the conveyor because some of the product are nitapon siya ng tumba, no? Paspas sa tayo. Okay, mas gadali siya, nagkabalik-balik, no? Miski nag-ampas, nagkagas-gas, no siya. So, kung hinayasab tayo, ang madagan, dili siya matumba, pero gamay sa kay product maabot at that location at the same time. So the problem is, unsa man gyud ay kapat unsa man kahinayon, unsa man kapaspason, o unsa man gyud katama-tama lang ang speed niya. Nga mumove siya, nga dili sad siya matumba, nga ma-maximize ang speed ang product na madala, no? So that's the problem here. So anyway, the problem, plated conveyor belt transports solid cylinders up a 15-degree incline. The diameter of each cylinder is half its height, meaning height is equal to 2d. The problem is, determine the maximum acceleration for the belt without tipping the cylinder as it starts. Okay. So, muna to ang duha ka scenario akong ipresent kiniya ako. Kung kusog sa kaya ang pag-accelerate, dako ang possibility nga matumba, no, matumba. So, unsa may metabo nimo kung nagtindog ka sa bus niya, kuha ka bantay nila gud pakalit ang bus. Sobra sa matumba, no? O matumba gid ka, di ba? Matumba gid ka kung wa ka kapangapot, no? Tumba ka. So, mo nang metabo niya. So, kung hinayan na sab niya, gamay ra siya madala dito per hour, no? Gamay ra ang product madala per hour. Kung paspasan, posible sad nga gamay ra gyapon kay nga tumba man ang hulog, huwag madala. So, unsa man ang tama-tama ang speed nga way matumba, no? So, that problem is a problem in kinematics because it deals with force. Okay? So, solution using Newton's second.
Excuse me, sir.
Yeah.
Nag-share screen ka, sir?
Ay, sorry. So, wala yun. Thank you. Okay. Okay, this is it. Asa ba to? Okay. Share. Okay. So, okay. Muna nga itong leksyon class, no? Okay. First, I will repeat what I have said, no? So, there are three types of plane motion. Okay. Number one is translation. So, kanang translation is to move ang rigid body to another point. Is wala na usab ang iyang forma mo or gyapon, no? So, kung nagtindog siya, pag-abot yung speakers, tindog yung gyapon siya. So, kung naghapa siya, pag-abot speakers, hapa lang gyapon siya. So, kung na siya tabagong translation. Okay. The second kind of motion is fixed axis rotation. Wala siya nag-move, pero nagliyok gyapon siya. Sa matugiyok, nga wala siya nag-move. Kana de magtuyok, no? Kana magtuyok ka. Wa man kali-move ana, no? Wala man siya move. Just like electric fan, nga nagtuyok siya, pero wala na siya nag-translate, wala na siya nagdagan kayo sa side. Okay? That is the second type of rotation. So, distinct kayo siya nga classical rotation nga movement kaysa isa, no? Ang translation mo balin siya ang location. So, dili siya mabalin ang location, pero galihok yapon siya. That means na rotation siya. Ang third type is combination of the two. Tawag siya general plane motion. Okay? Pagdaga niya, pag-abot niya sa pikas, nausap na siya, no? Nausap na yung forma, wala siya nituyok. So, because ang general plane motion is about translation plus rotation. Okay. Now, when we go to the body translation, no klase no tayo. Rectilinear, doon tayo curvilinear. Okay? So, ang body is said to be rectilinear if it translates in a straight line. Now, how about ang curvilinear? Mao gyapon, no? Ni-translate siya sa other side, pero ang path ng gisubay is not a straight line, but it is a curve. Just like mulabay kag bato horizontally, because of the action of gravity, the stone will hit the ground eventually. Okay. So, that is rigid body translation. Okay. Kung sa may application sa problem na ito, karon, okay, well, this is it. Okay. So, we have here a conveyor, no? A conveyor. So, a conveyor is just the mechanism is just like a chain of the bike. So it is a closed loop, no? Na mutuyok ni siya. Pero ang diferensya lang sa cambier o sa chain sa bike is that ang chain sa bike hindi makargahan og mga product. Ang cambier has very wide belt that is being acting as a chain, no? Now, as to its mechanism, parehag yapon ang chain sa bike na driver, which is the sprocket na i-connect sa pedal, kini sa cambier, doon nagyapon ni siya mga driver, itawag natin mga gears, which is stored by an electric motor, no? The rest are just idler, no? So it is a closed loop. It will just go back and forth, no? Like that. Now, a cambier can be a horizontal, no? It can also be vertical. It can also be inclined. Okay? Asa may makita sa mga factories, sa mga industrial facilities, no? So, nga na. Basta ng mga factories sa mga canned goods, no? Mga so naana siya sa cambier para machine na gid ang magdala sa iya, walay tao, no? Walay tao ang magdala. Okay. So this problem is about a conveyor belt, okay? Naka-angle siya 15 degrees, okay? Something like this. Plated conveyor belt transports solid cylinders at a 15 degree incline. The diameter of its cylinder is half its height. Okay. So unsa may mapicture ninyo ani, no? Kung siya sardinas, meatloaf ba ni siya o corned beef, no? Tawag na lang natong sardinas kung mo lang sardinas. Yeah. Ang sardinas, ang height niya, mas taas kaysa iyang diameter. Now, in this case, the height is double the diameter. Okay? So, yun na. Now, ang pangutana karon is determine the maximum acceleration for the belt without tipping the cylinder as it starts. So, matumba dahil ng cylinder dahil kung buliot ang conveyor belt. Ang sa may answer na to, depende. Kung kusog, nga labi nagkalit, matumba, no? If you are on a bus, na naghunong pa, nga wala ka bantay, kaya nagsige kag tiks-tiks. Yeah, ikalit siya dagan, no? Ikalit siya dagan nga, pinakalit yun. So, in that case, matumba ka, posible ka matumba. Okay? So, kung ginayan sa niyo kayo, dili kita matumba. So ang tendency na ni in economic point of view, kung kusog-kusog siya kayo, gusto nila pakusgan para daghan product ma-transport from point A to point B. But the tendency is that mas taas man gud ang height niya kaysa sa kuan kanang okay ang tad kung San Marino nga itong oxygen na nga gamay itong flat kay dili kay siya matumba, no? Kung ani nga puma sa cylinder matumba yun, no? So kung paspas sa kayo, gusto nila paspasan, i-maximize ang product na madala dito. Pero ang problem is kung paspas sa dagan sa conveyor, dako ang chance ng mga tumba siya, wala na madala. One, this kaya paspas noon, nagpagaras-garas noon siya, no? So ingon na. So, hinay na sab kayo, mga gihapon, gamay na product madala dito. So, the problem now is an engineering problem, no? It's about kinetics. So, determine the maximum acceleration for the belt without tipping the cylinders as it starts. Okay. So, this is a problem about Newton's second law. So, we use Newton's second law, that is mass times acceleration. Actually, it's the acceleration that is unknown. Okay. Now, we will also consider the geometry of the can. Okay. So, if we try to see here, this is the can inclined at 50 degrees. Well, dako ang makainin at 15 degrees. Mga naman 25 degrees, no? Nasayap ko pag-drawing no? Okay. So, as the incline moves, so, dapat wala siya slippage, no? So, meaning that this force here is zero. Dapat zero ni siya. F is equal to zero. The frictional resistance between the can and that one. And then there is as the can moves, there is a force generated due to the Newton's second law, that is mass times acceleration. And that force is along the direction, opposite to the direction of the movement. It is always opposite, no? Like for example, nagpindot ka sa bus, ni move siya towards the north. Di man ka matumba pa sa north, matumba ka pa sa south. Okay? Why? Because as the floor of the bus move to the other direction, there is also an opposite force, which is mass, your mass times the acceleration of the floor on the opposite direction. So the two are equal in magnitude, but they will create a moment, no? Because they are not tawag nila coincident with each other. Okay. Now on the vertical, there is also the weight of the can, or yeah, we are talking about can, which is mass again, and then the gravitational attraction. Okay. While on the vertical reaction, there is the vertical reaction of the this one, and maybe the vertical component of the mass times acceleration. Okay, so it moves up. So ni kuan siya, no? Okay. Now I'm talking about the geometry. No? So I draw here a triangle. No? So the green triangle in this object is as a x and y. No, the x is equals to the radius, while the height is 2 radius, because the height is always twice the horizontal. So I will make that bigger here, no? Bigger. Okay. So ako din pala pagayo. Okay. This point up to that point is what we call the R. Okay. Because this point up to this point is what we call 2R. Okay. Now the height also, okay. This is R. If this is R, then the horizontal is what we call R cosine of 15 degrees, because the angle between them is 15 degrees. So this is R times cosine of 15 degrees, the horizontal distance. The inclined distance is R. Now the inclined distance of this also is 2R. This is 2R. Okay. If this is 2R, then the horizontal distance of this, which is this one, is 2R times sine of 15 degrees. No? Times sine of 15 degrees. Now we are solving x. Okay? We are solving x. So, but we know already the total length, which is r cosine of 15 degrees. So that means that x is equal to r cosine of 15 degrees minus 2r sine of 15 degrees. So, from the geometry of the can, no? From the geometry of the can, we use the trigonometric equation to solve for x. We solve x actually here. So solving for x, so you'll have r cosine of 15 degrees is equal to the sum of x plus 2r sine of 15 degrees. Again, makita na ito na din eh. Kaya siya is equal to the sum of x and 2r sine of 15 degrees. Okay. Now, at the tip of it, you have here the mass times acceleration, and in the vertical one is the mass times gravity. Okay. So we go back, we solve only the value of x. Why we need to solve for the value of x? Because I am going to sum up moment somewhere here. No, if I will call this, point O. This one. Okay, I will call that as point O. So let point O. We let point O be the point of contact between the cylinder and the conveyor belt. No. Okay, so as the can is about to tip, hapit na ni siya mo tumbling, and the only point na in contact is point O, no? So as it is about to topple or about to tip, okay? So that could be a convenient point to sum up moment, no? Okay, so that no tipping happens, summation of moment about O should be equal to 0. So that means that from this diagram, you have the mass times acceleration. The right line of action actually is not passing through O, but it has a height of 2r or d, 2r. So rotating about O in a counterclockwise manner. So maybe that's positive. Okay, so mass times acceleration times 2r, positive. And then the other one is minus. Why I use minus? The explanation is that about O, MG is still to the right of the red axis, no, of the y-axis. So X is here. So this is point O. So if this force makes moment about O, it is rotating in clockwise rotation. So opposite siya sa 2R, no? Eh, moment siya, ang tawag na tuog, in G, in G, in G na siya. Then, kinimihirapit mo sa itawag na tuog, so, in A, in siya, in A, okay? So, about O, muna siya point O, also point O. Okay, about point O, the MA rotates at a distance 2R, while MG rotates at about X. Now, the other forces which are acting at O does not make moment. Actually, there are only two forces that makes moment, and they rotate in different rotation direction. So 2ER times mass times acceleration times 2R minus mg times x is equal to 0. Now, to simplify, you cross out m because that's common to all. Okay? So, then you have only 2er minus g. X is actually equal to, we have solved that already, r cosine 15 minus 2 sine 15 degrees. So, you substitute that here and equate that to 0. So, you can solve the acceleration equals to 0.2241423 of G, of gravity. So, what is that? It's equivalent to 2.1988 meter per second squared. So, greater than 2.1988 meter per second squared, that means that the can will topple. But if you limit only the acceleration up to 2.1988, well, nothing will happen to the sardines, no? So, itong mga sardinas o itong mga cylinder. So, maabot siya dito, no? Now, kung minus sa ani niya, posibleng gamay ang po ng product na maabot kay nga naman, gamay ang acceleration, gamay sa velocity. Okay? So, that is the third problem class nga kung giingon sa inyo, ano? So, do you have any question? Huh? Do you have any question, class?
None so far, sir.
Okay, so, wala pa sa kabot ng 11:30, hapit na yun to. So, ang akong buhaton is ako itong i-upload ang atong lecture karon tulo to ka problem na included there is the assignment. I will also create a page where you submit your assignment. There's only one problem, no? Just to exercise the problems of kinetics, no? The third thing that I am going to say is that it will be submitted. The assignment shall be submitted on next Saturday, no? On our meeting. Okay? So, I've heard kanya wala na question, so I
Question, sir.
Sabilia,
About
yes.
question about midterm, sir, si Vince Wong.
Why? May question ni Wong. Anong, ikaw ang abogado ni Wong? O naaba si Wong? Wala.
Wala sila internet, sir.
Mali
Nag-run
sila.
out daw. Wala daw. Nag-run out daw sa ila tong midterms. Then nag-email siya, then wala pa daw
Pag-asang din si Wong, day. Asa ni siya? Pag-asa? Pag-asa ni si Wong Tabilia?
Nangutaan pa ko, sir.
Wala ka kayo,
Sir, ako sab sir, wala po take sa exam sir kay. Wala sa mo. Burnout sab sa amo, diri sa amo sir.
Asa mo yung dapat?
There is a Butuan, sir.
Sa
Butuan.
Butuan.
Yes,
Si
sir.
Wong dulu Butuan yapon dili.
Wala o kabalo, sir.
Okay. Si Wong absent ka man?
Naa siya ganina sir, nawala daw ang internet.
Nawala ang internet. O, sige. Actually, tawag lang ko sa ilahan, no? I will message them when I'll be able to take. Actually, ako pa bang ugi-check kung kisagay wala ginagatik para akong time dili masayang, no? This is not the only subject I am handling. Okay, so, I can give them a midterm exam, pero it depends upon the time, but it will surely come, no? So, I will just message them. So, siguro kamo wala may problema, kaya nakumana mo. Again, I assure them na wala yung problema niya. Hindi ang time nun sa pag-take, di pa na ako ma-finalize kay I am still tracking those people who have not yet taken the midterm exam, no? So, that's it. Okay?
Okay, sir. Thank you, sir.
Yes sir, salamat sir.
Isa ko yung banwa ka take kanili, tiyog lang para maakit na to, no?
Ay katong kami ni
Ko sir.
Dara pa o ebidensyo o test, sir.
Lagi akit mo to silang darapa, di ba? Darapa is I think in the other class. Si Obidencio. Obidencio. Si Puentes. O sa man to?
yes sir.
Puentes, nakatik ba niya? Wala.
Pentes wala sir. Katong
Lagi napagito si darapa. Kita kayo uban. Si isa pa si Kilab. Wala makatik si Kilab.
Hilab sir.
Kilab. Akit.
Kanang
Wala na. Kita pa. Di tingog ko nung na wala pa. Kaya pwede ponista.
Bayata, sir.
Balita. Ako naman kung ikaw ganyan.
Thank you,
Kung
sir.
balita, Obidencio Puentes, darapa, Kilab. Kinsa pa iwa na mention. Nga wala ka-take. Okay, so sakto lang, no? So I will, as I have said, ako to siyang i-upload. Mo to siya itong lecture notes for this morning, no? And then also I create a page for your assignment. Okay? Thank you.